Hello and welcome to this week's Focus on Geothermal Energy for the Weekend webinar. My name is Alexander Richter, I'm the founder of ThinkG Energy. The webinar is brought to you by ThinkG Energy and our partner in Germany, Energize. Today I'm very pleased to have with us Dr. Hamed Soroush, the founder and CEO of Teverra. Teverra is a consultancy focusing on subsurface solutions for optimized carbon storage, energy storage, geothermal, and oil and gas operations. And he will talk to us about future for geothermal with the use of innovation. And with that, over to Hamed, and you have the possibility to ask questions, which we will then combine after the presentation and bring them forward as much as possible. And with that, over to you, Hamed. Thank you for joining us.
Thank you very much for introduction. Hello, ladies and gentlemen. I'm very pleased to have this opportunity to basically talk to you and present to you today. A big appreciation goes to the ThinkG Energy for the invitation. So as you know, we're going to talk about geothermal, specifically focus on the role of innovation in widespread use of basically this unlimited thermal energy which is beneath our feet. So when we talk about, of course, innovation, we should always talk about challenges first. So I would start the presentation with overall challenges against energy transition goals that we are through it right now, and then specifically talking about geothermal and the challenges that has stopped geothermal from becoming the #1 choice of energy, considering its potential for the whole basically community. Why it's not, and then how technology basically can help to be a vehicle to take geothermal, unleash the real potential of geothermal. I will give you some examples of the technologies that have been basically under development and how these technologies are addressing these major challenges. I would like to basically tell you upfront that this basically whatever I present here is based on my understanding of the current market and current technologies, and the examples that I'm showing you by no means basically is for promoting any specific technology or company, is based on my understanding, and also there are many other technologies out there that maybe I'm not aware of, or I don't see the importance as the one that I'm presenting today. And at the end of the day, basically we look at the future outlook and conclude the presentation. So I really want to appreciate your time being listening to my presentation, and I think we have to basically, I will be able to answer your question at the end of the presentation to make sure that I honor the time that I'm given. Okay, so maybe you have heard the term dual challenge. When we talk about energy transition, people are talking about this main problem that we are trying to solve. And what dual challenge is, basically, the population is increasing and we need to give more energy to more people. Why? Decreasing the emission. So what it means we are dealing with a dramatic increase in the demand of energy, and at the same time we are trying to eliminate. I don't use the word eliminate because I don't think it's appropriate, but minimizing the role of oil and gas, which is one of the major sources of basically carbon emission, right? So this is a big challenge. How we can replace new sources of energy that can basically fill the gap that we are artificially creating by trying to minimize oil and gas, and at the same time being able to satisfy the demand, right? So when we talk about sustainability, there are some major goals that we are trying to achieve, right? #1 being reducing emission, increasing energy availability while we still need to maintain or even improve the public safety, economic prosperity, and operation integrity. Right. So these are the main goals then that we are following with under umbrella of energy transition and sustainable, basically energy. Um, there are several challenges associated with these goals that needs to be addressed. Um, one of the biggest one being basically the need for displacing well-established markets. The main one being oil and gas. 160 years of dependency on oil and gas, right? Very well defined, very well basically established market, and we look at basically it oil and gas is involved with all aspects of our life. If you look at you around your place you are sitting right now, you can count many products that are coming from oil and gas. How we can basically change this, shift basically this market while improving energy and process efficiency. Uh, we have several novel technologies in hand right now, but deploying them at the scale is a big problem, right? So also, energy transition is a very evolving, dynamic market. How we can innovate in this environment, right? Everything's changing so quickly. New energy sources are coming to the pictures, new demands, new basic policies. Basically, I mean, people who have been in this environment for the at least last 5-6 years, you see how quickly everything is changing, right? From policy all the way to technology and technical side. Is a very challenging environment to innovate in it, right? And then defining standards for new technologies, another challenge that we are facing. So uh, there are two main gaps I would call here. Gap in knowledge. So to tackle some of these challenges, we don't even have the knowledge. We need to gain the knowledge. Like 160 years ago when we started oil and gas, a lot of knowledge that we have today didn't exist. So we had to basically build up this knowledge and make sure that we optimally use our resources. Uh, there are areas that we have the knowledge, but we just don't have the tools that we need to address these challenges, right? So these two are the key. We have to improve our knowledge, increase our knowledge, and we have to innovate and bring new technologies, new tools to the market to be able to basically tackle this challenge. Now, let's specifically look at geothermal energy. And I strongly believe that everybody in this meeting already knows the value of geothermal energy. Geothermal energy is renewable, is abundant, is reliable, scalable. Is it has minimal land use compared with any other renewable energy sources, and of course one of the lower carbon footprint that geothermal has, right? So just to give you a little bit of flavor of potential that geothermal has, according to NREL, if you go 5 kilometers below the surface at any location, basically, um, so we have commercially accessible energy today, right, which fully satisfy the U.S. electrical demands, right? It's the biggest statement, right? So, and it's true. So this is the potential of geothermal. And then if we go 7 kilometer depth, so the energy is even 5 times bigger than that, correct? So the fact is that geothermal is everywhere. It's just a matter of how deep we need to drill to get access to it, and how expensive it will be to get access to it, correct? So, however, the growth, at least in the US, this basically graph that you see here, it shows a comparison between geothermal, the green basically curve, with solar and wind. And you see that in the last basically several decades, geothermal growth has been really stable, providing minimum contribution into the basically energy industry. I think is historically it has been less than 1%. But as you see, wind basically picked up pretty quickly in early 2000 and solar early 2010. So they are basically growing very fast, and geothermal was kept behind. The question is why? With this much potential, why geothermal is not basically gaining a significant portion of the energy market? So to answer this question, of course, we need to look at the challenges. Number one challenge, regulatory and permitting, right? Unfortunately, the regulations for geothermal is not very clear. Permitting process is very time consuming. So it delays project, it delays development and also increase the cost. And this is a negative basically for investors who are the main basically vehicle taking a technology to a commercial level, correct? So how we can tackle this problem here, the role of government become the most important uh, solution for this problem. Governments play a major role in geothermal or any new sources of energy, right? If you ask me which countries would be the most successful uh, countries in geothermal development, I would say look at the government and see how much support geothermal gets from the government. And that defines basically which countries will be ahead of other countries, I mean, in the next decade. Right? So it's very important to make it easy for companies, for operators, and for investors to work together to basically unleash the real potential of geothermal. So number two, financing and investments. Again, it's very important that money comes to a new technology, new energy source to pick it up and take it to where we want, right? Unfortunately for geothermal, the upfront cost of project has been quite large, and then the payback period is typically very long. There's another negative that keeps the investor from widely invest in geothermal energy. So how we can address this one, I believe technology becomes very important, uh, specifically for this challenge, because we need technologies that lower the cost of geothermal development. Uh, Technologies that give us wider access to the resources, to the deeper resources, to the lower temperature resources, and also technologies that help improving the economy of the projects. So whatever technology that we even think of bringing to the table needs to be fully looked at from techno-economic point of view. It is a very important keyword to make sure that this technology will help with the economy of the projects, right? So in geothermal, we are not like oil and gas with lots of basically income and profit coming from the project. So they have the beauty of, I mean, going for most luxury projects, right? In technologies, geothermal projects are low profit margin, right? We need technologies that lower the cost. That's the key point for technology development. And one of the other keywords that is very important is this common language between technical people and investors, which is missing today. So I think geothermal community at the moment doesn't have that clear and common language with investors to pass all the values of geothermal to them and bring them to invest on geothermal, right? So we are improving. There are several companies that are doing great right now, but the number of them are less than basically the number of fingers in your hand. We really hope that with technology we can improve that significantly. So geographical limitations. As you know, currently conventional geothermal is limited to certain locations where the heat is reasonably close to the surface. Like in the US, California has been historically the center for geothermal, right? Eastern US, nobody look at it because, I mean, the fact is that there are geothermal resources, but they're too deep, right? So this is one of the limitation that basically make geothermal less accessible than wind and solar. Again, technology becomes very important here. How we can expand our reach and our access to geothermal using new technologies. Resource challenges. When we talk about geothermal, two parameters become the most important parameters: temperature and permeability. We need high, basically, temperature resources, and we need reservoir with permeability, so we can basically produce the hot water and harvest the heat, correct? So how can we improve that? How can we reduce the dependency on the natural temperature and the permeability? Again, technology, and I will give technologies that we are developing today that address all these challenges in a few minutes, but again, technology plays a major role here. So to me, geothermal needs enabling technologies that address these challenges and at the same time lower the cost of operation. These are the two main things that we should look at when we think of technology development. Okay, so I think based on this slide, I'm trying to say that technology is a big player. Innovation is very important in this space. But for these innovation technologies, there are specific needs that we need to address. And to me, there are two major needs. Again, just to recap what we talked so far. We need to drill deeper but cheaper. Why? Because if we go deep, geothermal resources are always there, right? Why we haven't done that as of today? Because of the cost, right? So we need a new drilling technologies, new equipment tools to be able to drill faster and cheaper, right? So we can go deeper. And the second one, harvesting more energy from less temperature. I think it's critically important to have technology because, as everybody knows, currently the biggest challenge, technical challenge with geothermal is low efficiency of converting thermal energy to electricity, right? If you want to use uh, basically direct heat, everything looks good economically and resource-wise. But when we talk about conversion to power, efficiency is a major challenge right now. So can we improve our basically power plants, ORC systems that are currently available to harvest more heat from lower temperature fluid? This is a major challenge, right? So major need for technology development. So based on these needs, again, to my perspective, there should be specific targets for technology development. Number one, lowering cost of drilling. Reducing geothermal drilling costs is a significant focus of current research and development. As you know, drilling can account for up to or even more than 50% of the total cost of geothermal projects. Several technologies and approaches are being developed to make geothermal drilling more cost effective. So these emerging technologies combined with ongoing research and development aim really to make geothermal energy more competitive by lowering the high cost associated with drilling. So this is one area that really need work, innovation to improve what we have today. Lowering exploration risk. So again, geothermal is currently location dependent. If you come to Georgia, Atlanta, where I'm sitting today, and drill a conventional geothermal well, you fail because we know that there's no resources at the depth that we are expecting to see geothermal in California, for example, right? So to lower the risk of basically geothermal exploration, we need to target super hot rocks that we know heat source is always there, right? So we know that every well that we drill, we will get to what we want. Okay. So expanding geographically. So yeah, hot resources reasonably close to the surface are limited to a specific locations. But we have medium, low temperature resources almost everywhere. How we can improve the economy of geothermal projects to be able to bring all these resources to the energy mix, right? Developing high temperature tools and electronics. You know that a lot of technologies from oil and gas are transferable to geothermal. And I think that this last several years of communication interaction between oil and gas and geothermal has been really helping geothermal to move faster because there are knowledge and technologies that we are transferring from oil and gas to geothermal, right? But there are areas, there are technologies that fall short when we talk about high temperature, right? They're not designed for high temperature, specific, I don't know, bits, downhole sensors, logging tools. We need to upgrade those technologies or develop new technologies that help us basically deploy those tools to geothermal. And increasing power output and scalability is another main target that we should have for technology development. With that said, I would like to actually walk you through some of the attempts that different technology companies, innovators are working on it around the world, and see how they what challenges they're trying to address here. Okay, and again, I'm just going for the technologies that I'm fully aware of them, and I see the value. By no means is covering everything going on and we don't have to basically walk through all those technologies that are developed right now. So let us start with the low-hanging fruits. We talked about the cost of drilling for geothermal. Yes, it's 50% of the project cost, but there are millions of wells around the world that have been already drilled, mainly for oil and gas. Can we convert some of these oil and gas wells to geothermal? And the answer is yes. Not all of them, but a specific percentage of them are basically have the potential to be repurposed for geothermal production, either heat or electricity. So doing this, we basically eliminate the cost of drilling new wells. We are using the available resources. We are using wells that have been in use for many years, resources that we have been has been characterized for many years, right? We have all type of information that we need to spend millions of dollars to acquire them if we drill a new well, right? So we have access to all those information historically. And this is a real definition of energy transition. When we talk about moving from oil and gas to clean energy sources, this is exactly what energy transition means, right? Converting those assets that have been basically emitting carbon historically now to generate green electricity. Economically, we are we are postponing the decommissioning cost of plugging and abandoning those wells, which is a huge liability for companies and sometimes for the government if company doesn't take those responsibilities. And then expanding the life of those billion-dollar assets for several other decades and generating clean energy, right? So a lot of people basically debate this movement, this idea, and they mainly say that the oil and gas wells are not designed for geothermal. Yes, that's totally true. These wells may not produce hundreds of megawatts of electricity, right? Because they're smaller than geothermal wells. There are other issues with them, but again, they're low-hanging fruits. We are not proposing this as a replacement for drilling new wells. It's just a solution, right? That if we don't have technologies today to give us huge access to geothermal resources, we can start with low-hanging fruits, this well, right? And generate lower amount of geothermal, but I mean, why not? So just to give you an example, like this is the map of US with all the oil and gas wells, and also the map of temperature at the, I think it's at 3 kilometers. And you see that actually, I mean, majority of oil and gas assets are already on the hot locations, right? And specifically looking at Texas itself, you see, I mean, the density of the logs and the temperature, the wells and the temperature is a very, I mean, it's a very good sign actually to show the potential of converting latest stage or even, you know, uh, uh, abandoned orphaned oil and gas wells to geothermal. Just to give you a little bit of a few numbers, in December 22, the Railroad Commission of Texas, they announced that there's about 1.3 million wells in Texas inventory, right? And then in April 23, they announced that 162,000 oil well and 87,000 gas wells are active in Texas. A quick calculation shows that we have about 1.1 million idle wells in Texas only, right? And according to Teverra's experience, we looked at actually many wells around the world. Depends on the location, 5 to 10% of existing oil and gas wells have potential to be repurposed for geothermal, right? So it means that in Texas, if we, again, don't quote me for this, but if we had opportunity to go and look at all these wells, 1.1 million, many of them are plugged and abandoned. We cannot even look at them, right? But it's just assumption. So we had opportunity to convert 88,000 wells, and each of these wells have potential to generate anything from 100 kilowatt to 1 megawatt of electricity, right? So we are talking about 8.8 to 88 gigawatts of electricity, and it is not a small, right, opportunity. So the main question here is that which wells can be converted? Is it economically viable, right? And I'm aware of a few projects that people try to convert oil and gas wells to geothermal and they fail because they didn't answer this question. Techno-economic is become very important, right? So what we did at Teverra as an example for technology to start with, we developed a tool called ConvertDeck that looks at not only temperature and produced water, which are the two parameters that basically everybody look at when they want to see if the well has potential. We look at 100 parameters, from reservoir parameters, geology parameters, well integrity parameters, even the market around the location, the infrastructure around the oil field, and do a full techno-economic analysis to basically even come up with the price of electricity generated by those wells, or the cost of the heat generated by the wells, right? And this de-risks these projects, right? So we know exactly which wells have potential, and we can spend our money and invest on those wells. So moving forward, enhanced geothermal systems is one of the most promising technologies out there for geothermal energy. I'm pretty sure most of you have been exposed to this technology. The challenge that this technology is trying to address is basically those geographic limitation and the reservoir requirement. We need permeability to be able to produce geothermal. So this technology said, okay, there are abundant, basically amount of hot dry rocks out there that there's no fluid or minimum fluid in them. So how we can inject fluid and harvest the well? We need to create artificial permeability ourselves, right? So horizontal drilling, hydraulic fracturing, a technology that basically revolutionized oil and gas 2 decades ago, now is coming to help geothermal to become more efficient and basically widespread. Okay, so we have a lot of knowledge from oil and gas about this technology, right? We know how to drill horizontal wells, we know to do hydraulic fracturing. We just need to customize it for high temperature, hot dry rocks, right? So so it's 10 times more energy produced using enhanced geothermal system than conventional geothermal. And it needs drilling multiple wells from single location, with basically lower the cost, the risk, and surface footprint of no geothermal development. There are companies like Fervo, like Alterock, Sage Geoscience that are working on this technology. Forge is a basically DOE, Department of Energy funded projects like field uh, laboratory that aiming to test different technologies related to enhanced geothermal system in Utah. There are a lot of activities, at least in the US, because in Europe, I know hydraulic fracturing is banned and you cannot apply this technology, which is the big, basically, missed opportunity, I believe. Um, but when we talk about hydraulic fracturing, it's all about risk of induced seismicity, risk of uh, basically contamination of drinking water. If we do everything properly, we can address those challenges, right? So it's all about appropriate optimal design and optimal basically uh, modeling of what we are going to do. So I call it learning from 160 years of oil and gas operations and applying it to clean energy space. Very nice example of this. So closed loop geothermal systems or advanced geothermal system is another technology which basically specifically aim at removing the risk of subsurface complexity, induced seismicity, uh, unlike enhanced geothermal system that you are dealing directly with the reservoir, injecting fluid and harvesting heat from the reservoir rocks. Basically, you drill wells, bunch of wells, right? Like creating a radiator under basically in the reservoir and isolating them and harvest the heat by circulating fluid into those basically pipes, right? So it really minimizes the risk of subsurface, right? The natural fractures, heterogeneity, anisotropy, and this type of thing. So and it has no risk of induced seismicity, of course, no water consumption. It has flexibility in design with minimal surface impact and longer operational life because of less complexity involved, right? Uh, Again, Ever is one of the pioneers. Green Fire Energy has their own technology that basically is a downhole heat uh, exchanger. They use single wells. Ever has their own basic design. They create a complex well design to do this energy harvesting. Uh, but the whole objective is minimizing the subsurface, the surface and environmental risk. So talking about drilling, one of the most promising technologies that we have heard of and is actually moving quite quickly is quasar millimeter wave drilling technology. It has the potential to drill deeper, hotter, and faster. It can go to 500 Celsius and 20 kilometer basically depth. Uh, Targeting hard, super hot rocks, no exploration risk because we know that if you go that deep, the heat is always there. Uh, it meant to lower the cost of drilling significantly. So it is totally different from the conventional basically drilling with bit. What they do, they use a gyrotron to create millimeter wave energy to basically melt the rock and drill the rock, right? So it really lowers the risk of downhole tool failure because it's more I mean, it uses minimum no electronics. So this is an advantage. The challenge that is basically addressing is geographical basically limitation. Right now, we can drill deep at any location and access the geothermal energy. So now we talked about drilling. I want to actually talk about the discipline that has been basically recognized in the oil and gas industry for the last 50 years at least, or 60 years. Geomechanics. Geomechanics has really helping oil and gas industry to drill well safer, to maximize production, to minimize risk of basically completion and hydraulic fracturing failure. Is all about understanding the mechanics of the earth with respect to the changes that we apply to the subsurface by different operations that we are doing, drilling wells, injecting, producing, all these changes had the reaction of rock formations, and this is how the risk is generated in the subsurface environment. right? So, I mean, if I want to talk about numbers, roughly every year geomechanics is saving about 4 billion US dollar for oil and gas industry, right? Now, is playing the same role for geothermal, of course, right now. So it's extremely important for enhanced geothermal system. It's extremely important for drilling those complex well patterns for advanced geothermal systems. But the biggest challenge against geothermal has been always lack of uh, well logs, which are the main input to geothermal, to geomechanics. So we can do geomechanics when we have appropriate and good quality logs, right? Dipole sonic being one of the most important ones. And you think of, I mean, I've been in geomechanics for more than 25 years, and it has been always my challenge. Do you have dipole sonic? No. Do you have good quality density? No. I mean, even if they have, the data is only the reservoir. How about the overburden? There's a big limitation in horizontal wells. We cannot run wireline. So we never have logs along the horizontal wells. This is why we cannot optimize our frac design in shale gas, basically development side. So grand challenge is dependency of geomechanics on well logs and availability and quality of those logs, right? So one technology that we have developed at Teverra to basically address this challenge is removing the dependency on logs totally and generate all the or estimate all the parameters that we need for geomechanics using drilling dynamics data. Basically, we look at the drilling parameters and the drill bit vibration data, which seems to be a very rich data set. A lot of information about the subsurface, also, although it's very affected by drilling parameters, drilling configuration as well. So it's very complex set of data, but very rich. And think of Bit being the first basically logging tool that touches the rock. It can capture the most reliable and intact information. And think of logging being basically done several hours or days after drilling, and a lot of changes in the downhole environment. So they don't really give you that intact information, right? So we developed a technology called DDG, drilling dynamics geomechanics, and it has been tested in 10 different locations internationally, offshore, onshore, geothermal, uh, shale gas, basically, and it is working well. We can extract all the rock mechanical properties and in situ stresses and pore pressure, which are all the parameters we need for geomechanical modeling from drilling dynamics data with no logs. And then it enables us to have geomechanical model from surface when we start drilling all the way to the end of the well, right? And artificial intelligence, machine learning is the key driver here. So we developed a physics informed machine learning technology that uh, is combined with the advanced signal processing to basically process the data and convert the data to geomechanics. So now we talked about natural geothermal sources. In many places, we don't have shallow access to geothermal economically because it's too deep. But we have other renewable resources. We have other heat sources that we can harvest those, we can pick up those heat or excess energy that will be wasted and curtailed if we don't use them, convert them to thermal energy and store them subsurface and generate what we call it synthetic geothermal reservoir, right? And we can do it almost everywhere that we have access to waste heat or waste energy from renewable, right? So, and the fact here is that rocks are ultra long-term batteries for temperature. They can keep the temperature for 6 months with more than 90% efficiency, right? How we can use this potential to do energy storage, right? So it gives us the ability to integrate with installation with excess heat or power. It gives us ability to recycle waste heat, and it's very scalable and uh, geographically it can be used almost everywhere. So the concept is to basically pick up the excess energy from renewable, drill wells to a cold, basically aquifer, produce the water, heat that excess energy, use that excess energy, heat the water, and store it back in the reservoir. And then whenever we need electricity or heat, we can basically produce this hot water and use it the way we want. So turning subsurface to a gigawatt scale, thermal battery is a huge opportunity, actually. So a little bit about future outlook and emerging trends. So policy supports investment and incentives are very important for geothermal to grow faster. Of course, environmental and social impacts are very important. Geothermal is already low emission, low environmental impact technology. We need to even improve it more. Technology advancement, as we discussed, expansion beyond traditional regions is very important. Closed loop and enhanced geothermal systems are very basically promising. Low temperature geothermal is a big opportunity. We need technology to be able to actually harvest the heat economically from them. Repurposing oil and gas wealth is a option that we have today. We don't have to wait 10 years, 5 years to have it basically in the market. And integrating with other renewable like solar, wind, hydrogen is very important. So geothermal is base load and can cover basically any other sources of renewable energy which is not base load. And digitalization is very important. AI and machine learning with respect to gathering, integrating data, and creating meaningful insight to what we are doing. So conclusion, I think I went far beyond my time. So I just go through this slide and I'm done. So as conclusion, so geothermal has potential to become the top choice for clean, resilient, and renewable energy. And this is the belief that everybody in our geothermal community has. Major challenges, regulations, economic constraints, and technical difficulties are the main points of basically challenge, the barriers. Advancement in technology is crucial. So for overcoming almost all these basic challenges. And governments become the most important player in regulation side. There are many technological dead ends. We are still, with all the technologies that are being under development now, there is still gaps in basically technology environment needs to be addressed. Co-operations is the key. I really believe that nobody is competing in a new area like geothermal. We are all in the same boat, and we are striving to get to the same target. So I really want to invite the whole community to avoid any type of competition. All these technologies that we are discussing, they're all type of cooperations, making geothermal be more profitable, more efficient, and make it the #1 choice for the world, right, for energy. And then technology is the engine, investors are drivers. It's very important, right? So whatever we do in the technology side, we are creating that vehicle engine to go faster and more efficient. But if we cannot bring investors to the table, we don't have any driver to drive this. So creating that common language between technical team and investors is critically important for the fast growth of geothermal energy. Right? So with that said, I would like to thank everyone for taking the time and listening to me. And I don't know how many questions we can take today, but I'm more than happy to answer any questions.
Thank you, Hamid. I think very interesting and a very good summary of the challenges faced in geothermal. Touching upon some of the points, of course, I have a lot of comments and thoughts here, but one of the key themes seems to be that drilling cost is so expensive and that we need to work on the drilling cost. And what we, I think, experience in the industry is that one of the key themes is seen to speed up drilling. And that's all nice, but it seems like the cost of all the materials and services around the drilling beyond, let's say, the drilling time and the drilling rig has actually increased significantly. So all the cost savings, I think, with speedier drilling is maybe not as significant. Kind of what would be your take on that?
Yes, that's totally true. And unfortunately, I mean, the cost of material, the cost of even operations is increasingly um, uh, increasing. And again, that goes. You know, when we talk about a totally different technology for drilling, like instead of using bits um, and a drilling system that needs a lot of material and advanced sensors, now we are moving toward more like energy-based technology, which doesn't have that limitation, right? So I think that really helps to tackle this material problem and cost problem. So we need a shift change, not just improving in the current technologies when it comes to the drilling, right? This is my perspective on this. So we need totally new concept, and there are a lot of rooms that still available to come up with crazy ideas. They're crazy today, but maybe in 10 years from now, they are not crazy, and they remove the dependency on expensive material and expensive, sensor technologies. I don't know if I could answer the question. So roll out technology again.
Yeah, no, indeed. I mean, the technologies. I mean, I guess there's also a little bit of an interesting, let's say, difference between, let's say, the North American view on geothermal and its challenges, and kind of what we experience in Europe. That is essentially the understanding, let's say, that geothermal from an electricity perspective is probably a more challenging
Exactly.
technology with regards to competitiveness that is probably seen in the United States. So here, technology is seen as an opportunity to make geothermal competitive in the electricity sense, but we see this focus on heat, and you touch upon that by kind of looking into when you mentioned going into medium low temperature kind of regions, and with that expanding the use of geothermal. And in that context, I think the interesting question here is for what you when you refer to repurposing oil and gas wells.
Hmm.
And the commercial viability of that, I think, is quite often seen as one of the challenges. And here the question is that a lot of these wells are, let's say, located not where you need the energy or where you have infrastructure to take off that energy, be it transmission lines or the heat directly. So the question is basically, what do you see as opportunities to kind of solve that conundrum?
Okay, very good question. Uh, yeah, all those basically challenges that you mentioned with respect to repurposing oil and gas wells is true. And this is exactly why we developed that screening tool, because we look at the location of the oil field, we look at the accessibility to grid to end users, right? And as I mentioned, there are low percentage, like 5% of the wells that can be converted, right? So currently, I think the solution is just to target those wells with potential, right? But how we can improve that in future to be able to basically convert more number of wells to geothermal, of course, improving the heat transportation, right, is one of the limitation. I mean, compared with electricity, electricity you can basically transmit it to very basically far away areas, right? It's easy, but heat you cannot, because you lose the heat if you put it in the pipe and send the heat, I don't know, several kilometers away. So we really need to either create new markets close to those oil field, right? Or we come up with game-changing technologies for basically transferring heat to a longer distance. Again, another technology gap, right? To take the energy to closer to the end user. Uh, this is what I can think basically. And talking about ORC systems, they're very enabling technology with respect to repurposing oil and gas wells, because Uh, all of them have basically a minimum working temperature, which is roughly around like 100 Celsius. But from technology to technology, it's different. So for your information, if we can reduce this, let's say 100 Celsius, right? If we can reduce this minimum temperature, working temperature, for 5 degrees, you can double the number of wells that can be converted to geothermal. And you see that the huge opportunity here, right? If we can improve ORC to harvest economic, basically energy from 5 Celsius lower temperature, we can double the number of the wells. That 5% becomes 10%, and that 8 gigawatts becomes 16 gigawatts, right? And we don't have that technology, we don't have that capability today.
Um, yeah, of course, I mean, here come a few questions as well. Let's say a bit more on the general side of things. I mean, not everything is about technologies, of course, and there are questions about, let's say, local acceptance and things like that. But
Yes.
like I said, it's something that kind of maybe technology developers can't answer, but maybe in the context of expanding the regional usability of geothermal beyond, let's say, the current areas, kind of creates probably more challenges and more need of engaging with the public. So how do you see the need kind of in that technology innovation concept to communicate kind of what is possible and also kind of be realistic about what technology can do?
This is a very critical question. Basically, how we can pass the value of new technologies to the community. And to me, of course, community care about carbon emission, they care about green energy, but at the end of the day, they look at their electricity bill or heating bill at the end of the month, right? And if we cannot translate our technologies and relate it to that bill and reducing that bill, it doesn't go anywhere with community, right? So we need to be able to show the community that new technologies, like we are talking about hydraulic fracturing. So in Europe is a no, right? Because I mean, it's not environmentally friendly. And we know in technical, community, we know that if we do it properly, it is safe, right? Uh, so, but if we show the community that with using hydraulic fracturing, enhanced geothermal system, we can reduce your bill to half, I don't think anybody is against it. So at the end of the day, basically translation to money, to saving, helps to better sell new technologies while we are trying to, of course, help with the environment, the carbon emission, and this type of things.
Okay, and then maybe one of the final questions. Of course, you mentioned EGS, talked about closed loop. Um, and I guess we've seen, let's say, a change from EGS in the early days when we talked about EGS, let's say in the earlier 2000s. We talked about, let's say, a relatively open hydro shearing kind of approach, while we now, with the new EGS systems, the way I understand it, let's say a more localized stimulation process, kind of more targeted. Um, from a cost perspective, I mean, we've seen announcements of lower drilling costs, etc. But like I said, we said earlier, the cost of the services remains relatively high. So the question, where do you see, let's say, the price level, in particular in the EGS technologies and the drivers here, how that will change and make EGS commercially viable?
Yeah, so this is a question that I think needs to be asked from EGS developers. As of today, I don't see actually a lot of announcement about the economic side of enhanced geothermal system. They're definitely more expensive than conventional geothermal, far more expensive than solar wind. One of the objective of technology development is to keep improving the technology, the methodology to reduce that cost, right? I cannot give you numbers because I'm running after these numbers and I don't get these numbers from those developers, right? And the reason is that I'm in the earliest stage of development. Of course, we cannot expect EGS to be as economically, attractive as well-established technologies. Uh, but I know it's higher than what it should be, and I know that they're working hard to basically bring this cost basically down to make it more attractive for basically industry, for community.
Okay, and I think, and with that probably coming to an end, but a last question. I mean, you mentioned data, you mentioned collaboration, and the need here to kind of really create some sharing about data so we can, as an industry, move forward based on what we learn along the way. Um, do you
Um,
agree with that? And kind of how would you see that's best to be done? I mean, should developers be more open about things, or how do you think that this could be achieved?
Yeah. So let me look at. Actually, you brought me to something that I always recommend our clients because historically in oil and gas, whenever companies want to cut the budget, they start from data acquisition, right? They start right there, and then later on in the development phase, they pay 100 times more to basically the cost of not having enough data, right? So one thing is to make sure that we spend enough money to acquire data to understand the reservoir subsurface. And it helps us quite a lot to de-risk the project and save a lot in the development during development. So this is my recommendation to all geothermal companies not to repeat the mistakes that we did in oil and gas, right? And then sharing is caring, right? So sharing becomes very important. Again, we are all in the same boat. If we keep the data to ourselves, if we don't, I mean, if I'm working on advanced geothermal system and you are working on enhanced geothermal system, there's no harm to share the knowledge and data. And we have to create that. I mean, we are much better than oil and gas with respect to sharing information and data in geothermal space. And it needs to be improved, right? I still see some flavor of competition between some of the technology developers and operators. Uh, we need to work hard in conferences, in public, basically seminar, webinar, like what you are doing, to be focused on creating an environment which is more cooperative and more knowledge sharing, and hopefully we all become one, basically energize collaborative community toward making geothermal number one choice of energy for the whole world, right? I think a lot of education, a lot of seminars like this can help removing all this basically barrier against sharing data.
I think that's a very good end, I think, to our webinar today. Ahmed, thank you so much for joining us today. Um, and thanks for taking the time. And with that, I think wishing everyone a good weekend and hope to see you at the next webinar. Thank you, Ahmed, again.
Thank you
Bye-bye.
very much. It was a big pleasure for me. Yeah. Have a good one.
Bye-bye.